Now, getting into our next bit with scientific thinking is a way for us to prevent ourselves from getting fooled. There are going to be people out there who make false claims for many different reasons, and some of those reasons might be nefarious. They might have bad intentions for you, or they simply don't understand the science either, and they're making claims based off of their own faulty logic. Popular media often cites two types of, quote, scientific evidence as fact, and we want to make sure we know that these two things are not fact, right? This is not part of our scientific thinking process. The first is pseudoscience. Pseudoscience sounds like science, but it's not backed by evidence. So a lot of times with pseudoscience, you see a lot of buzzwords like studies show, or according to our studies, or something like that, even though they probably didn't actually do any sort of real rigorous scientific study, right? They're going to use a lot of buzzwords, and you want to look out for those buzzwords. You're going to have a discussion thing about that, so I'm not going to get into it too heavy here. Moving into our next one, we have our anecdotal evidence. This is where we only have a couple observations, or maybe even only one observation, that someone jumps to a conclusion to try to find a link between two things when that link's probably not there. A lot of times I think of anecdotal evidence as like stories. Someone says that they did X and it caused Y to happen, but there's no actual scientific evidence behind it. They simply are maybe seeing a correlation or seeing something and drawing a link between the two. So for example, your aunt says that, or she put lemon juice on a bruise and the bruise faded faster. Well, that's not a scientific way of going about it. She's the only one who's done it. She doesn't know anyone else who's done it. It's not scientific because there could have been other things that caused her bruise to fade, including just her natural body healing, right? The natural healing process she goes through. So that would be anecdotal evidence. So I like to think of anecdotal evidence as like a story someone might tell you, hey, I did this and it worked for me. Well, that's great. Maybe it did work for you, but we don't actually really know that because there's no scientific evidence behind it. And our sample is literally just like 1 or 2 people. It's really, really small. Number 3, if it sounds too good to be true, it probably is. So this is common when you're reading like news articles or something from a non-scientific entity, that the claims are almost outrageous. Something like, drinking red wine will prevent you from ever developing cancer. Well, that sounds fantastic. I'm a wine fan myself, and if drinking a glass of wine each day made sure I could never get cancer, I would do it in a heartbeat. However, that's a pretty big statement to make, and it sounds too good to be true. That's because it is. Drinking a glass of wine is not going to stop you from ever getting cancer. A lot of times when you see something like that, it's because someone has read a little bit about the science behind it and has gravely misunderstood what the science really stands for. There could be a correlation, or it could be a study that was done in a petri dish and not in a human body, or could have been made into quantities that are not found in natural things. Like it's a way higher source than what you would find naturally. So there's a lot of things that can go into it. And again, we'll talk about those in our discussion posts. But again, if it sounds too good to be true, it probably is. Number 4, superstitions. Superstitions are irrational beliefs that are not based in logic, right? That things like luck. So some sort of belief that if I do something, then I'll have this outcome, right? If I knock on the door 3 times, then something will happen. Or if I only buy my lottery tickets on Tuesday, I'm more likely to win. There's nothing backing that. There's no science, there's no logic saying that Tuesday is a really good day to win the lottery. That's just a belief that I'm holding that has no logic, no rationality behind it. It's something I just simply believe in a lot. So why do we care about people putting out anecdotes, pseudoscience, and superstitions? Well, bad science can be really costly. If you're relying on bad science, you might spend money on something that you otherwise wouldn't spend it on. And sometimes it can be outright dangerous. If we're not careful, we could actually get harmed by something. For example, it's not uncommon to see people make claims of herbal components or certain concoctions that they're selling to cure cancer. You see that one all the time. Everyone wants to cure cancer. But what happens if someone chooses to go through and get this untested, unreliable, quote, cancer treatment instead of getting something like traditional chemotherapy? Well, if there's bad science behind that concoction they take, they might not get their cancer treated with chemo, which means their cancer gets worse, and they could possibly die. Not only that, if they do end up finding out that their treatment that they've been taking on the side isn't actually doing anything, their cancer might get worse, and then they have to go get more expensive treatments down the conventional medical pathway. If they just would have done something the conventional way earlier, they would have saved themselves a lot of pain and money, not to mention their long-term health. So bad science can be expensive and can, in some occasions, cost people their lives. We need to make sure that we know that difference so that we don't end up on the wrong side of that problem. Science does have limitations though. Science is just about what is or isn't. It doesn't tell us anything about morals or ethics. So we can't answer questions like, is it right to do this? Or is it wrong? Science just is. The application of the information we get from that can determine right and wrong, but the science itself is without morals and without ethics. Not to say that it's unethical or not or immoral. It just is outside of that realm. It's a separate sphere from those two concepts. We can use what we learn from science to do the morally right or ethically right thing or the wrong thing. And we'll talk about some of those things throughout the semester. We also can't use it to study supernatural phenomena. So things like spirits, ghosts, gods. It has to be testable. And a lot of those supernatural phenomena ideas aren't testable. So we can't use science to either support or not support those things. Again, it's like a separate sphere from those items. Many of the modern scientific concepts can be used to describe events that seem to have supernatural origins. So this is one of those things where in the past we may have attributed something to the supernatural, like ghosts or spirits, and then because we learned more about science and we have better technology to create better experiments, we ended up showing that those supernatural origins were not really the facts, that there was something else. We found something in the natural world to give that an explanation. Think about some examples. In order to think about them, try to think back throughout history, before we had modern science the way we do today. So we get into some of our last things, and we'll talk about these again throughout the semester, but we want to talk about what is life. We've been talking a lot about the scientific process, but we haven't really talked about what makes something alive in the first place. And we'll get into that as we go through, but let's go through our short list. There's 6 main characteristics that every living thing shares. Every living thing, from the smallest teeny tiny bacteria to a blue whale in the ocean. Every living thing is going to be organized into one or more cells. So you have to be at least one cell in size, possibly more, but at least one. Every living thing has to use and transform energy. So we have to utilize energy. We have to be able to transform it into different forms of energy. Every living thing needs to be able to respond to the environment, and those responses can look different. You think about your own response, you can visually look around, you can touch things, you can taste things and hear things. Those are ways that we can respond to the environment. But something like a plant is going to use different ways to respond. They can detect light and move like their flower head, like a sunflower, tracking the sun across the sky. That would be a response to the environment that doesn't rely on the senses that we're used to. So it doesn't have to be something like sight or hearing or something like that. It can be kind of abstract, but no matter what, they have to be able to respond to the environment around them. Every living thing needs to be able to regulate the conditions and processes going on inside their body or inside of their cell or inside of themselves. And we call that homeostasis, right? Being able to maintain a relatively constant internal environment and regulate things that are happening around them. We can also regulate things based on the environment. That's something a lot of bacteria do. Every living thing also needs to be able to grow, develop, and when the big ones, reproduce. Living things must be able to replicate themselves, whether that's through budding or asexual reproduction or sexual reproduction. Doesn't really matter. Doesn't matter the process of reproduction, but the ability to reproduce in some form or fashion is a requirement. And then lastly, every living thing is subject to evolution by natural selection over time. We'll talk more about that last point in one of our later units, so we won't dig in too deep now. There's also two major themes that we'll go over in this course. One, hierarchical organization, so how do we arrange things and organize things in life, and the power revolution. Again, those are going to be some later units, and we'll get into those in more detail. So hopefully this chapter wasn't too bad. We covered a lot, and hopefully we're kind of opening our eyes to seeing what the scientific process looks like and realizing that we really need to be open-minded in order to go through this class and really take as much as we can from it. If you have any questions, let me know, and then make sure to bring your labs to lab and make sure to go over the lab safety stuff, which we'll do in person. Also make sure to work on that discussion post and read through the item about scientific resources.